Okay, so we've talked about parabolas, ellipses, and hyperbolas, and then we shifted them, shifted the centers, and then I told you we're going to talk about rotation. It's really about the rotation of the axes. You're not really rotating the figure. You're rotating the axis so that we can come up with new equations based on this new axis. Because we're going to be you're dealing with things where you already have the picture, but it's hard for you to come up with the equation. But if you could take the axes, let's say you had this for an ellipse. Let's say you wanted to know what the equation of that was. Well, it'd be great if your axis was like this, and then you could come up with it. So that's what we're going to do. Based on certain information, we're going to come up with a new equation of a parabola, an ellipse, and a hyperbola. Okay? So we're going to manipulate things. If you don't understand anything that we're going to do today, all you have to do is substitute and simplify. If you can do that, when I know somebody who struggles with simplifying difficult expressions, they have fractions in them, they have radicals in them. But if you can do that, then you really don't have to understand what it is you're doing. You're just kind of going through the motion. Okay, now, your reference sheet. I'm going to give you a big chunk of what should be on your reference sheet. You ready? So, X and Y, those are your coordinates that we're dealing with. Capital X cosine of phi minus capital Y sine of phi. So yeah, there's a little trigonometry. Not much. It's unit circle stuff. You still don't need your calculators for this stuff. But if you had to do something in a different degree, you could. And then you have capital X sine of phi plus capital Y cosine of phi. Given a coordinate, we ought to be able to come up with the new coordinates. So capital X and capital Y, what are those equal on the new axes? So these four things you're going to have on your reference sheet. Okay? So X cosine of phi plus Y sine of phi. Negative X sine of phi plus Y cosine of phi. Okay. This is what you want on your reference sheet. How do I know which goes, well, how do I know what to choose? So I'm going to choose. So these two go together and these two go together. If I'm given a point, so here we go, number 4. If I'm given a coordinate, -2, 1, and I want to have this rotated by 30 degrees, visually this is what we're looking at. -2, +1 is right there. We're not moving the point. The point stays exactly where it's at. What we are doing is we're going to rotate the axis and come up with the new information. So here's about 30 degrees. So again, I'm guessing this is my capital X axis. And then my capital Y axis is there. I want to know what that coordinate is as I rotate the axis. Now notice the point didn't change. So it's a different way of looking at things. If I have little x and y, the old x and y, how do I get the new x and y? Well, if I want the new x and y, then I'm going to use these two. Because all I have to do is now substitute that x and y into these expressions. Okay, so let's do that. We're going to write this down. Capital X, you got to put these little bars on them, equals the x cosine of phi, cosine, in this case 30 degrees, plus y sine 30 degrees. x is -2, y is 1. So as a refresher, on your unit circle, cosine is x and sine is y. Cosine here is the long leg because it's the x. So what is that value? Radical 3/2. What's the short leg? Amazing. You guys acted like you couldn't learn that. You guys are going to test out a pre-calculus and have to take Calc 4. Alright, so cosine at 30 degrees is what? Square root of 2, the x value. Sine of 30 degrees. Dun, dun, dun. And here we have, I'm going to write it like this for now, and I'll tell you why here in a minute. All over 2, they have a common denominator, so I put the numerators together. And I'll tell you why we're doing that in a minute. Typically, if this was my only answer, yes, you would simplify the 2's. Alright, that's the x, the new x coordinate. What's the new y coordinate? Capital Y. You got negative x sine of phi, 30 degrees, plus y cosine of 30 degrees. Everybody do this one. Just substituting, that's all you're doing. Got this? Who got that? Alright, so here is your new coordinate system, your new coordinate for this point. It is at -2 radical 3 plus 1 over 2, and 2 plus radical 3 over 2. This is why we don't have them separated, because if you separate it, then you have 4 fractions up here, it looks kind of strange. So we're going to keep them together as one fraction, okay? Even though you can reduce that. So this is your new coordinate for that point. Got it?
That's
Good so far?
Yep.
Not too bad. Great. Can I
We're
erase?
given the angle.
Yeah, they give you, this is what they give you right here. Okay. Alright, that's 1 point.
oh. One step.
It'd be great, instead of doing a whole lot of points, why don't we do infinitely many points by using an equation and converting the equation into a new equation. Okay, so that's what we're going to do right now. So we need a lot of space here. It's going to have a lot of fractions, a lot of radicals, but really it's just algebra. Leave this up here. We can use it. So let's say we have the equation, that's number 10. Y equals x minus 1 quantity squared, and we're going to rotate this by 45, the axes by 45 degrees. First of all, what is this picture? A parabola. Yeah, you have one square term. Yes?
Is that last problem to get the answer?
Yeah, the coordinate was the answer. But now what you have to give me is you have to give me a new equation. I gave you a coordinate the last time. I'm giving you an equation this time. This is the equation of a parabola. Centers at 1, 0. I want the new equation of what this figure is as we rotate by 45 degrees. So we have our y's and our x's there. This piece right here. If I want to convert this, so I need to put expressions into this. So the little x is this right here. So wherever I see a little x, the old x, I need to put this whole expression. Wherever I see the little y, I need to put this whole expression. So the y is equal to capital X sine of phi plus the capital Y cosine of phi. That's y equal to x, which is capital X cosine of phi minus capital Y sine of phi squared. Oops, I'm sorry, minus 1 squared. Very large equation now. So far, we're not done. Guess what we gotta do? You have to put like terms together, you gotta simplify. Meaning, you have to square that trinomial. Okay? So, for the sake of writing things quickly, you don't have to put these bars on again until we're at the end. Just remember that they're capital letters, okay? So I'm just going to write this out. What is the sine of 45 degrees and the cosine of 45 degrees? Yeah, now we're all excited about saying that. 4 months ago, you're all like, I don't want to say anything. Okay. So I'm just going to write it like this. We all know these are capital letters for now. Make sure on the quizzes, the tests, your homework answers have to have the bars on it if they're capitals. Got it? Now you got to do this. You have to distribute each term through. So this is going to get really long. So I'll do the first set with you, and then you have to do the rest of it. The left side still stays the same for now. Let you catch up, and then I'll work out the first part. Okay, so this times that gives me x squared. Radical 2 times radical 2 is 2, and 2 times 2 is 4. So 2x squared over 4 is the first part. Don't reduce it yet. This time the second one is minus xy, or 2xy over 4. Is that right? Yeah. And the next part is a minus x radical 2 over 2. Now you guys do this one. Yeah, I'll be able to do this. This is algebra. Right? Anybody not get that? And then now you have to do the last term. Pretty good. Pretty good. Okay. Now you can put all your like terms together. I only have one x term, x squared term, so I'm just going to go ahead and say that's x squared over 2. Done with that one. I only have one y squared term, so I'm just going to put that note in front, y squared over 2. So it's going to be a good idea to cross things out as you use them. Now I'm going to put x, y's together. Here's an xy, there's an xy, so a -2 and a -2 gives me a -4 xy over 4, which is just negative xy. Negative xy, any others? Alright, so minus xy. Remember, these are all capital letters. Now we'll do our x terms. So I have one on the left side here, and I can put it together with this one, so I subtract it over here. So a negative x and a negative x, that'll give me a -2 radical 2x over 2. Right? But then I have another one here, so that's -3 radical 2x over 2. So make sure you got that before we go on. Make sure you see where that came from. I can write it out separately if you want to see it. Okay, so I'm going to subtract the x radical 2 from the left. I have another minus x radical 2 and another one. So how many of those do I have? -1 minus 1 is -2, minus 1 is -3. -3 x radical 2 over 2. I just put the x on behind it. So your radicals have to be the same. Otherwise you can't put them together. And your variables have to be the same. So all I did was take the coefficients and added them together. This right here. This is where
That makes sense, but that doesn't mean.
it's on the left side of the equal sign. I brought it over to the
Oh.
it's on I brought it over to the right side. Okay, so that's how you get this. Now the next one, we'll do the y. Again, this will be a negative when we take it to the right side. A negative y plus a positive y. That goes away. But I also have 1 left over plus y. Equal 2 over 2. And I'm left with plus 1. And a 0 on the left. Where? This one? Okay, so this one becomes negative when I move it to the right.
Okay.
Which cancels with this positive 1, and I'm left with 1 left over, which is positive. Okay? Yeah, you gotta be very careful when you're doing this. One little mistake and the whole problem's wrong, right? So again, multiple points for doing it correctly. I can try to go through and see if I can find where you dropped a sign, but that would take forever. So, everybody's going to look very close to the same. If you miss it, it'll look very close to the correct way of doing it. All right, but the book doesn't like it like this. It doesn't like the fractions. So, and as far as I'm concerned, this is nice. Go ahead and take it one step further and get rid of your fractions. Multiply everything by 2. And that changes it. So this is what you get. So 0 equals x squared plus y squared minus 2xy minus 3 radical 2x because the denominator falls off, plus, probably should put the x in between the 3 and the radical 2, plus y radical 2 plus 1.
And those are capital, right?
Yeah, oh yeah, and at the end, make sure you put capitals so that we all understand that these are capitals. You can write them really large, but make sure you put the bars on when you're finished. Okay, now look at this. This is a crazy looking equation, but it's a parabola. Okay? Doesn't look like a parabolic equation, does it? All right. So when we rotate the axis, this is what that would be like. Now, some of these that you're going to do, they give you a strange looking equation, And when you rotate the axes, you end up with a typical looking parabolic or elliptical hyperbolic equation. Okay? So, just think of, you're only getting 6 problems tonight because it does take a lot of work, but the first part of it is our just coordinates. Alright, so you gotta get through that quickly and then get to the harder stuff. Here's your assignment. That's all it is, substitution and simplifying. You're going to do page 764, 3 to 13 odds. Okay, 6 problems. Yep. Again?
And then where's the first time?
Where'd you go?
I was gonna get a drink.
What if that plus one be able to multiply that by 2?
Oh, plus 2, yeah, thank you. Yeah, plus 2. Good catch. Yeah, I missed the problem, didn't I? Did all that work, I missed the problem.
Bonus points.